All right, so I'm going to start off with a story, and no, it wasn't a cold, stormy night, as Dr. Singh, but it's this facility that you see on the screen is what started my journey down the PON path, the passive optical network path. We actually designed this building. The main building here is 500,000 square feet. It's 5 stories, typical office building. But it is the tribal headquarters for the Choctaw Nation, so it's a very ornate. It's a very hell of a teepee. Good quote. They left that out of the brochure though, Tony. So, and behind it is a conference center, and then behind that is a full 3-level parking garage. So this monster we designed with a traditional copper network. And then, so we have steel out of the ground, and I get a call from the architect saying, hey, the nation's talking about switching from copper to a passive optical network. Have you ever heard of that? No. So don't panic, but we did. Panicked a little bit. So we started doing our homework. We did a lot of homework, and we'll kind of talk about that process and what we learned along the way. And design considerations that you guys should keep in mind as you go down this road. This is not a technical conversation in the sense that we're going to talk about what wavelength the lasers are firing down the glass. That's not what this is. Okay, I am woefully unprepared to talk to you about all the different, because then you get into gig, 10 gig, 40 gig bonded. I mean, it gets kind of crazy from there. So who in this room who is familiar with PON? So so has anyone actually designed a project around PON? You won't be there long, it's fine. So has anyone actually commissioned one and turned one up? Your client's actually using it. Yeah.
Oh, there's other ones, yeah. Ours is an underground.
Okay. Yeah, you're still in RFP stage, right?
No. Well, yeah, we are. We haven't got answers.
Yeah. Morning, Dave. How are you? Okay. So, well, let's talk about, the first question I have as a consultant when a client comes to me with something new is it reliable? Who else is doing this? What's the track record in the marketplace? Because that's a big facility, and by the way, it's not an insignificant building. It's their new national headquarters. So as we did some homework, we found some really small organizations that don't have much going on or using it, like the U.S. Army. Small little development in New Mexico called Sandia Labs. 200 facilities are on that. It's actually the largest active PON site in the United States so far. And then Kyle Field, Gigam. I'm getting no comment from the Aggie in the back of the room. So the PON network at Kyle Field supports 106,000 fans and can guarantee 2.5 meg per fan in simultaneous use. So you actually have people who are streaming content on game day in the stadium. I've seen it happen. Otherwise, I wouldn't be believing you that it's possible, but it is possible. They're an entirely converged Corning infrastructure. They're in the stadium, so their DAS, their Wi-Fi, and their GPON networks all run across the same fiber. And then the Atlanta Falcons Stadium, Mercedes-Benz Stadium, that is coming out of the ground as all GPON. So there's several NFL teams who are looking at this technology specifically because of the quality of the fan experience. That's become a big deal in building stadiums. It's not enough, it's not acceptable anymore for you to pay $200 for a seat and you can't post, you can't stream ESPN, you can't do any of the things you want to do. So from a fan experience, that's what's driving those numbers. Marriott, they have now standardized worldwide on GPON in all of their signature properties, and now we're seeing the lower properties like Fairfield, Spring Hill Suites, those brands are now adopting it. it's not required yet in those smaller properties, but the performance issue and the simplicity of managing the network in those smaller properties is what's driving the adoption there.
Is it here? This is America?
I don't know.
I don't think so.
Based on the quality of internet, probably not. Yeah, I'm not sure when the last room renovation was done here. I know the conference center's new, but I don't know.
LaGuardia is on the process now, about their airport.
Yeah, LaGuardia is Orlando's new terminal.
That's long.
Yeah.
So my first interaction with PON was at DFW Airport, and it was built primarily to serve all the concession spaces. And it wasn't built to support the actual airport operations. So why is PON growing in popular use in the United States? And a caveat is PON is not new. Have you guys all heard the term fiber to the home? You've heard of FiOS?
Yeah.
So fiber to the home's been in use in Asia and parts of Europe, and for fiber to the home in the United States for a long time. Well over a decade. It's new to the enterprise space. So it's not widely understood. So the adoption has been pretty slow, and it's been faster. The adoption's been better on each coast because of the density and the size of the projects. So the demands are, for bandwidth, there's what's driving the adoption rate, right? So we've seen bandwidth demand increased by 45x since 2012. It's going to double again, and there's no end in sight for those numbers. And the marketplace is very focused on providing flexible workspace. That's actually why the Choctaw Nation adopted GPON. They built that 500,000 square foot facility all on raised floors with demountable partitions that can reconfigure each floor plate without tearing out a single wall. So the entire infrastructure is either underfloor or above ceiling. So that building was built with 12 conventional telecom rooms, and we only use 2 today. Unfortunately, we were too far down the road in construction to actually take the rooms out, so they were already built. So this demand for flexible workspace, so we're putting more people in less square footage, and the commercial real estate markets are wanting to be able to reconfigure that space, not quite on the fly, but it takes effort. But they want a lower cost to reconfigure their workspaces. And this trend actually surprised me. So since 2014, IT budgets globally have actually been shrinking. Not dramatically, but we've seen a 3 to 4% decrease in the funding of IT staffing, which is actually surprising to me. But that trend appears to be sustaining. The other big factor in GPON is it takes fewer humans to manage the network once you have it built. Constant pressure. Oh, this is, how many of you have been asked by your architect to give up IT space? All of you. Or if you get that, 30 square foot triangle closet that they want you to put a rack in.
100 steps?
Yeah. So I had lunch with one of the guys at Chatsworth, and I said, Tom, I need a cabinet, a special cabinet. Will you make it for me? He goes, oh, Drew, we'll make a special cabinet. I said, you don't understand. I need it to be 8 feet tall in the back and 5 feet tall in the front. He said, Drew, I don't know if we're going to do that for you. So the constant need to reclaim square footage. Again, those highly reconfigurable workspaces, they don't want to give up the floor space. And we're also fighting for plenum space, right? The space above our beautiful ceilings is precious real estate. That's getting harder and harder to fight for. And then, of course, lead contribution. How many of you guys have been asked by your design team to find lead points, right? It's kind of hard to do. It's not impossible, but it's not off the shelf for us.
Hey, Drew.
Mhm.
Have you seen lead points awarded for any PON projects? I know we haven't, but
No, because I don't think we don't have a built network yet to actually apply through the lead process to argue.
Leads, they really don't touch on anything in low voltage at all. They
Well, so
recognize us.
well, good question, but the way we're going about it is we can see as much as an 80% reduction in network related power usage by going GPON. So that's the tact we were going to take, because if we're not building IT rooms, we're deleting, it's the domino effect, right? I can delete the power, I can delete cooling,
The other approach is consumables, the copper.
Yes.
Reducing it by copper, it's got an environmental impact.
Oh, huge reduction in material used in the network, absolutely. Right. So reduction in power, reduction in space, reduction in material. Has anyone actually taken the time to get that push-through lead? Not that I know of.
yeah, I don't want to, if clients ask us about PON, I don't want to say, yeah, you can get lead credits, but nobody's done it.
No, I wouldn't make that claim.
Exactly.
But usually you can get the architect's attention when you start telling them, you can save money. We're in a situation with a school in Central Texas. It's $3 million over budget, and by eliminating 5 IT rooms, I could give them back almost $300,000.
By backing out power, cooling, and fire protection.
Right.
You're giving back a lot of money.
Now, sometimes that's a little hard. You have to cooperate with your design team to come at those numbers, right? Because you have to get a little bit of cooperation.
Yeah, we don't run the HVAC numbers, so how do we know?
Right. Well, but your mechanical engineer will run it for you. I mean, with reduced loads.
If you find some time.
I think you can also get credit for having outside internet on the school. You set it up outside.
Oh, okay. So Wi-Fi access outside the building?
The last mile, I'm not sure Leeds giving too much credit on that.
Okay.
You probably get as much by putting the bike rack in. Oh, yeah. I had to put bike racks in a prison just to get lead feeds.
Okay. So the PON. So can anybody tell me what the actual definition of PON is?
Passive optical network.
Passive optical network. What are the other terms you've heard?
GPON, EPON, was it now 10 GPON?
There's a lot of them. So passive optical network. You'll also hear POL, passive optical LAN. They're the same thing. It's just different terminology. GPON is actually a reference to the GPON standard, which today is 2.5 gig down, 1.5 gig up. So it's not a synchronous standard, but XGPON, which is the 10 gig standard, is synchronous, depending on what manufacturer you go with and what lasers they put in the boxes. So yeah, there you go, XGPON. The latest standard, and I don't think I put it on there, is NGPON 2, because we need more acronyms. Next Generation PON Generation 2. So that is the 40 gig PON standard, and a couple of manufacturers are actually working to be able to bond to 40. You're really bonding 8 10 gig channels together, so you could arrive at 80 gig. I don't know that that's been released commercially yet, but it's just about to be available. Nobody's using it. Verizon was testing it, carrier grade network stuff. So fiber to the home, we already kind of touched on that. One of the neat developments though is Verizon is probably the most aggressive with the carriers in building out GPON networks. They have a lot of money, and they've shifted all of their resources, of course, to wireless and to all fiber infrastructure. There is a city in Florida that right now today you can get 8 gig service to your home. Now they don't sell it, but the test network is up and running, and they actually have an entire neighborhood running at 8 gig. So your PS4 will sing like it never has before. So
down in Chattanooga, there was power company and fiber to communicate all their devices and take care of the reliability of their system. And when we did this, they added extra strands, so they actually took fiber to the homes of all the
So broadband, building out broadband in rural areas or underserved areas is a thing that the United States government is very interested in promoting, and there are several funding streams available to the carriers and to the rural electric cooperatives who know how to go play that game. So the FCC is a big player in that market, and of all things, the U.S. Department of Agriculture. Don't ask me to explain that. I don't know. So the USDA has a lot of money available to entrepreneurs, to CLECs, to rural electric cooperatives who can actually demonstrate a business plan. There's a lot of strings attached. The FCC money is on a 10-year grant cycle, but you have to spend 40% of it like right up front. I mean, so you have to have a plan. You have to know how to get under construction quickly, or they'll cancel the grant. They'll cancel the back end of the grant. So that's how a lot of these smaller CLECs are building these really fast, pervasive fiber networks in the middle of nowhere. It's your taxpayers at work. I'll let you decide if it's a good use of your taxpayer dollars or not. I don't know. So technically, what is a passive optical network? Well, it's really pretty simple, right? So we have an optical head end. We have a single strand of fiber that goes to a splitter. A splitter is just a passive device. There's all flavors of splitters. The two we use the most in the commercial and enterprise space are 32-port and 64-port passive splitters. And really the big difference there is you can do one fiber in, or you can do two fibers, and it depends on if you want redundancy. If you want that layer one redundancy, you can build that up. Some manufacturers are using that second fiber actually to bring different frequencies of light into the same end equipment. So there we go. Reasons to go fiber rich. Well, we kind of already talked about it. So the network designs that we've actually built, we can use 1/10 of the space of a traditional network. That's floor space. We still are using space, but because most of our infrastructure is passive, I can put it in a cabinet in an electrical room. I don't care about electromagnetic interference anymore. I can put it in ceiling enclosures where you don't see them. I can put them in the floor. The limitations of where I put it really are, we really don't have many limitations other than if you have to make decisions about how you're going to get power to your edge devices, and that will dictate kind of where you put your equipment. 80% less power, that is, I'm sorry, Joe?
How are you seeing that being received by the IT groups? Because now you do have semi-active gear that wind up in a ceiling, or like you said, an electrical room, or it's not in their traditional IT space. Yeah.
So I will.
Are they embracing that? I guess is the question.
I would say for the most part, our large enterprise users fight PON. They really do. It's a big education. It's a quantum leap. I like to tell people it's not like switching brands of detergent. It's like changing your religion.
Change your operation.
So you have to change the way you think, you have to change the way you design, and it changes the way you maintain your network. So
it changes your control level too, about where they're controlling that equipment from.
Yes, yes. So from a physical securing the physical equipment in the network, it changes some things there too. So in your critical infrastructure, high security areas like airports, processing plants, anything where security is a higher concern, then you have to think through what kind of enclosures am I going to use, where am I going to put them, how am I alarming those, all of that. So
what I'm seeing in aviation is they're winding up, if they look at PON, they're almost architecting it like it was a copper traditional network. They're putting the same rooms and the same closets.
Very typical, especially if it's a renovation and they already have IT spaces built, you'll see them resist giving those spaces up. So, I'm sorry.
But I still have my 100-meter limitations from the switch to the desk, right?
From the edge device, which is called an ONT, an optical network terminal, which is at the end of the fiber.
Okay.
That's where your channel link starts.
End of the fiber after the splitter.
You still need to switch it.
So, and I'll show you here in just a second. We're almost there. We'll go through architecture real quick. You can imagine, especially think about the size of your cable bundles now when you're with Cat 6A, right? We have clients now that are standardized on 6A across the board. It is a tremendous space hog and requires a lot of pathway, right?
The bundles in CAT are going to change because we just got the 100 watts.
Right.
So now you get a
The new 802.11 standard, have they officially ratified that yet?
Yes.
Okay. So that will absolutely drive your bundle sizes down.
and shorten your distances because of the heat.
So yeah, cabling is a pain, especially when one of our case studies is a historic renovation, and you'll understand why PON won out, because they just couldn't get cabling from A to B. And the reduce IT maintenance cost. This one's sometimes where you'll feel some pushback from your client's IT group. The example I give you a little bit later is from Sandia Labs. They reduced their IT staff to maintain their network from 15 to 1. Nobody lost their job. It's the federal government we're talking about. They're just doing different things, right? So they're doing, and then the network manager actually spoke at the Telabs conference, and he said, yeah, all those people, we were way short of headcount we needed, so we weren't getting to the productive projects that they should have been engineering. Instead, they were running around. Could you imagine maintaining a Cisco network across 200 buildings on 5 separate secure networks for the government? I can't even imagine what that's like. But the related maintenance costs, part of this is energy. We're using less power, right? Part of it is I need fewer people because my network management becomes easier. And the other piece of it is this equipment, if you stay with the 3 big enterprise folks, Nokia, Telabs, or Zone, their equipment's telco grade stuff, and their mean time between failure is 25 years. They don't have planned obsolescence in their PON networks like we do on the switch side, on the copper switch side. So we have a lot less equipment to maintain, and it costs us less in the long run. Give you an example, the ONTs, which are, think of it as an intelligent media converter, they're $300 at the end. I mean, these are not expensive components. Most of the failures I've seen in PON have been power related. You know, they're pretty resilient, but you can, if you put them in a closed box in the desert in July, you're probably going to cook it. So here's where you get a little, hopefully this will be a little clearer to you, Greg, as we start talking about this. So this is a picture of the same kind of networks we've been building for 25 years, right? Very copper heavy. So we have our MDF, or our data center, and we're branching out to our separate buildings on campus. So we've got all of our distribution switching, and now we're going out to our IDF closets, where we have all of our layer 2 edge stuff, and then we're connecting all that copper back into our IDF rooms, or telecommunications rooms if we want to be the 21st century. And how many of you have seen this picture before?
Oh, that's actually pretty clean.
It's not bad.
You're like, I can see the floor. That's not bad. Well, you know, the good news is they haven't blocked all of the air movement in the racks, just most of it over here. And that guy's getting his TV out. I guess he wants to watch the game while he's... So you can, and this is the optical LAN layout. It's much cleaner. So we start here at the OLT, which is our optical head end, right? It's the brain. This is what uplinks to your core switch. So if you're married to Cisco, Extreme, HP, at your cores, that doesn't have to change, because really all we're doing with PON is I like to say we're installing a 12-mile long patch cable.
The OLT is your layer 2 switch.
So PON can handle all your layer 2 functions. It can handle security. It can handle all your VPN routing. It can do intelligent detection. It can and automatically assign a port to the VLANs. It can do all of that layer 2 stuff that
128-bit encryption.
128, and that's changing too. They're going up the food chain with that too. So Joe, go ahead.
Question on, yeah, 'cause I, modern understanding. I thought there was a limitation though on the number of VLANs that.
It depends on the manufacturer. It depends on the software that's managing the network.
Okay.
Yeah.
I thought there was a limitation there. Okay.
Yeah.
Well, I
We-
see converged networks now.
We have, yeah, we expected to have that problem with Choctaw because they run an ungodly number of VLANs, but we haven't had an issue.
Okay.
So you're putting,
So our OLT, it's going to be in our main equipment room in the building. Now, it doesn't have to be. If your buildings are within 12 to 20 miles, depends on what manufacturer and what laser you use, you could actually use one OLT and put your splitters out in on your campus buildings. Now, most people don't deploy it that way, truthfully. I don't know how Sandia deployed their OLTs. They don't tell us that much detail. So OLT in wherever you choose to put it, either in your data center if you're close enough, or in your main equipment room. Single mode, and we're showing a single strand, but obviously we'd never run just a single strand. But so you're hitting your passive splitter. Now I don't care where the splitter is. In large facilities, like the larger the building, we like to push the splitters as close to the edge as we can because we want to reduce the amount of fiber that we're having to pull in the building. Now, Joe, you mentioned earlier that our legacy network guys get real nervous when we start deleting their closets. So it's not uncommon to see centralized splitters in what used to be your IDF or TR rooms.
Does it have to be single mode? And you're always using lasers?
Today, everybody's on single mode. Tel Labs has now released a splitter that can take multi-mode fiber in. I don't know why you'd ever. Their whole point is if you're doing a renovation, you're doing a retrofit of your network, you would never run greenfield multi-mode. There's no reason for it. Multi-mode costs more. I mean, the lasers obviously are less expensive, but we just by rule don't ever even have a multi-mode conversation when we're talking PON. Yes, sir?
Between your splitter and your end devices, that's fiber as well?
Yes. So I have one strand of fiber coming in to the splitter, and then I'll either have 32 or 64 strands going out.
So we're eliminating PoE.
No.
Drew, I want to repeat the question, please. I mean, from that end, so we can capture it.
Sure.
Where's the microphone? Yeah, where's
Yeah. Where is the microphone?
To recap, the cable between the splitter and the end devices is
Right here.
a fiber.
Yes.
And my question is what's going on with PoE?
So the ONTs, the media converter at the end of the fiber, are PoE capable depending on what model you buy. So we're actually injecting power at the edge. Now, you're getting into an interesting conversation about how we power those edge devices, and we'll get to that later. I promise you we'll answer your question.
so you're pushing the switch closer to the devices.
Exactly.
Sticking it someplace. So you're pushing the switch closer to the devices and putting it in a ceiling or a floor space, but not in the data room. Am I hearing you say that?
Right. So that ONT device can be, it could be one port, it could be 24 ports, and anything in between. They're obviously usually 4, 8, 12.
It's actually placed in the wall, like a data jack.
Is it a special switch? So I've eliminated this, I have replaced the switches I have in now. If I have layer 3, if I have a layer 3 or layer 2 switches?
It's a layer 2 device. It
Okay.
replaces your layer 2 edge switches that you would have in your IDFs, traditionally speaking.
The OLT does, the ONT is just a media converter.
Yeah, the ONT doesn't really have much intelligence. It's smart enough to phone home and figure out what to do.
Okay.
Does that make sense? Yes, sir?
I recently you were talking about how BIOS.
This microphone thing.
You recently said something about earlier on about FiOS. I just recently upgraded my FiOS, and they had to put a whole new ONT in, and it's a fiber. I mean, all the way up to the house. It's not like at the street and then Cat 6 over.
Right.
It's all the way up to the house.
Right.
One thing that I noticed was we had a power outage, and there's no longer any battery in that ONT, so for battery backup. So is there any resolution for backing up the network in the
Yes.
system going down?
Yes.
Okay.
So it depends on how much money you have. So we can solve that problem in a number of ways, and we'll get to that conversation here in just a minute. But yes, it's a very important question in an enterprise network, absolutely, and even at home, right?
Right.
So this is a traditional copper LAN. So let's talk about what goes away, what changes. Obviously, I can eliminate my distribution switches because my PON network is going to take over that role. Our access switches go away out of the IDFs. And then all of our special systems to support those IDF rooms, right? Fire suppression, utility power, backup power, all of that stuff goes away, and I can probably downsize my generators depending on how extensive my backup plan is. And then I can eliminate all of that copper. So all of my pathways can go away, or a vast majority of my pathways can scale way down or go away altogether. So that's an enormous win in a new construction. So what do we replace it back with? Obviously, we talked about our OLT. Again, that's the mothership, and all of our edge ONTs are going to phone home to mom. We're going to go back with our passive splitters. And now in this case, we're actually showing a series of 2 splitters. We don't actually do that very often, but it can be done. So now we're showing fiber all the way out to your ONTs. So my category cabling is reduced. I can tell you at Kyle Field, now I didn't go check, they say their longest piece of copper in the stadium is 30 feet.
But you can take 100 meters off.
Right, your link limit starts here at the ONT. So if you need 100 meters, you can take it.
So your ONTs where you need your power.
There you go.
Yes.
So your ONTs where you need the power.
Yeah, so ONTs.
And also at your POH.
Right.
And OLT.
So there's a number of ways to do that. I can centrally power my entire network. The Choctaw building is on a 48 volt DC power distribution. It's slick. It is not cheap. It's not for the faint of heart. But we only have 2 sets of batteries in the entire building because at Choctaw they have redundant OLTs because they have more money than God. So we run a completely redundant OLT chassis configuration, which is unheard of unless you're in healthcare. So, yeah, airports would absolutely do that. So,
If I've got to have
but for a commercial customer, for an office building, a fully redundant optical network's pretty overkill. Hey, it's your money.
a lot of our clients want a segregated network, so I have to have 2 of these, right? If the client doesn't want to be on the business network, would they have to do 2 of these?
If they want physical separation, yes.
Okay.
If they'll go with virtual separation, then we can obviously.
So you're using your fiber for the communication pathways, but you could have separate switches
Sure.
if they want to.
Absolutely,
okay.
you could.
Gotcha.
Yeah, I mean, we've actually had that request where you have deployed 4 ONTs in the field. 2 of them go to a different OLT because of, we had one client that insisted on a separate network for PCI compliance, although we didn't win that argument. It's not necessary by standard to do that, but it makes them feel better, and that's what we did. So,
Drew,
yeah,
are there
absolutely do that.
practical limitations? How many times you can split that light signal based on optical light budget?
Yes. So what you do is our design process is completely inverted on PON because we start at the edge. We figure out what devices that you want to connect to the network. We figure out what their bandwidth consumption is, and we figure out how many ONTs, and we figure out how to load balance across those ONTs, and then we back into the number of splitters and the number of PON cards we need at the head end. See, on traditional copper, we're used to starting in the in the data center and or the main equipment room, right? And thinking out. We do it 180 degrees differently in the PON world. So yeah, you have to do a little more work from a design perspective to understand what you're going to attach to it and how to spread that bandwidth across.
How big are these ONTs? I mean, I thought a high school project.
Didn't we have 2 mics at one time?
Yeah, there should be another mic here. But since I have this, I'm going to ask the next question, Dave, sorry. Drew,
Yes, sir.
do they ever use wavelength division multiplexing on these devices so that you can get effectively separate physical channels?
Yes.
Y'all know what I'm talking about with that? Okay.
That brings up a follow-up question.
So they, depending on the manufacturer and depending on what flavor of GPON you're deploying, you use time division or wave division. And for example, Calyx uses both. So as I remember, like Calyx will use wave division downstream and time division upstream. So they separate the data channels.
Remember, we can do the video and everything off of these ONTs.
Right.
Based off Ray's question, that's not 2 physical cables though, is it?
No.
That's splitting the one. So if we had a need for 2 physical cables, do the LANs accept 2 cables?
To the
Or the LNT,
no,
sorry.
No, you'd have to have separate ONTs.
Right.
Connected to a physically separate fiber and splitter infrastructure. Yeah, so Tony, you bring up a good point. The other reason hospitality has really latched onto this and why DFW Airport deployed it is because it's what they call the triple play. I can ship voice, I can ship RF, and I can have a really big data pipe. So I can actually deploy traditional cable television across the pond. Nobody buys traditional cable television anymore, but you can do it. We can also, using a product called COM2000, you could take DirecTV or Dish, ingest that into a COM2000 server, and then distribute it back out as IPTV.
Also, he's seeing references to audio now, going over it.
Yeah, so the Choctaw project deployed AV over IP, and it is running across the pond. It was painful to get it running, but it does work. And it works with, there's no latency. That's the big win. PON networks process information much, much, much faster, which is how Kyle Field can support 106,000 users. They're not using a big pipe. They're just processing. When you request to send information across the network, it's serving your request and getting rid of you as fast as possible.
Now, I guess one question that kind of follows up on that, and then of course video came up. I've seen and read a lot about different PON implementations where it's a short request, a lot of bandwidth down, TV, IPTV, FIDS, GIDS, all that type of data, and it's great at distributing out. I guess my concern is how's the flip side of that work where I have high megapixel, large count IP TV system or CCTV surveillance systems where I'm flooding data up because now I don't have the controls that I had in a traditional network. And I'm just hammering.
Well, I do have controls, right?
Okay.
I can still VLAN all that traffic off, and I can apply QoS to that. Just
okay,
like I would.
So it allows for QoS
Absolutely.
still. Okay. So yeah, I just haven't seen that implementation yet.
It's a good question. It's a function of the management software, right?
Yeah. So you should touch base before you go any further that this all is dependent upon a management platform.
Yeah.
That you have to have.
Yeah, completely. So the big differences today, really, between the 3 big PON manufacturers is really their management interface. Tel Labs is old school. It looks like what you'd find in a telco central office. It's not pretty. It's command line. But once you know how to use it, you can be lightning fast.
Have you seen any deployments out of the ground complete with high video count?
Yes.
Okay. I talked to the manufacturers and they reference all these installations that I know are coming out of the ground now. They're not in yet.
So the Choctaw Nation building you saw between the parking garage conference center and the main building is about 600 cameras. They're all 2 meg or higher.
Okay.
Running at 15 images per second, running, I think we're storing somewhere around 5 or 6 months of
So
video.
it's about a quarter of some of our implementations. Yeah.
Stadium in Atlanta is running this on the PON network, and they have I think over 1,000 cameras.
Okay, yeah, because that's, I mean, I'm looking
Wait.
at 2,000 and 3,000 camera.
Yeah, so the
sites,
key
you know.
with video, right,
Yeah.
so is to distribute, like, you don't want to take 8 4K cameras to one ONT, right? I don't want to take the chance of saturating
Sure.
all my upstream bandwidth. Now, when you go to XGPON, now I'm 10 gig synchronous, I don't care so much.
Yeah,
but-
that's what I've heard. I just haven't kind of
A-
seen that
Again, it's the
implementation yet.
planning process.
Yeah.
Tony can attest. You guys have been through it. You have to think. You have to be thoughtful about what you're putting where. For example, I'm not going to deploy 4 access points on one ONT. Right? I'm going to split those across 4 because I want to be careful. I mean, the network is robust to handle it. You know, QoS will intervene and stop me from degrading the rest of my network, but you still don't want to. You don't want to lose information if you don't have to.
Yeah, exactly. I can do audio microphone monitoring over it.
Audio microphone
I've
monitoring.
got cameras with
Sure.
microphones, okay?
Yeah, it doesn't change.
Great, okay. So I had a question.
So I've got a high school project, and it's a renovation, and it's a nightmare to try to figure out where to put all the copper. And I've actually started working on an idea that I didn't realize was similar, as I call it, distributed IDF, but traditionally it was 2 fiber strands to a ceiling cabinet and a 48-port switch and patch panel. What's the size of the ONTs? And you said there's like, 4, 8, 12, 24, something like that. How big of a box are we talking about?
Depends on the manufacturer and the number of ports and the number of.
You can get them as low as 2 RU.
Yeah, because Atlas IED makes a 2 RU ceiling rack that's a 2x2. It's pretty slick, actually.
Right.
And you can put cooling in it.
Yeah. So we've seen, I think Choctaw's tradition is just about all 8-port ONTs. They're in ceiling enclosures. They're racked in there very nicely and cable managed, just like you would any other network cabinet, network device. So the form factor is kind of all over the place, but the one you'll see the most of is about this big. But you can do single port ONTs. It depends on what you want to do. They make 4-port. I think 4-port's the most I can put in a single gang wall mount box. I think you can buy that in 2 or 4 ports and a single port.
And then you can run 120 right to it.
Yeah, absolutely.
They ditched the 2-port.
Did they ditch the 2-port?
It's the same chip in the back. And
Nobody was buying
nobody
them.
was saving money anyway,
So the form factor varies dramatically based on the manufacturer. So, but when you get into the 4 and 8 ports, which is what most everybody's buying, they're not much different across those. In this slide says they can, this particular manufacturer, this is based on Tellab's number, they can support 7,000 ports. Other manufacturers, those port count, and that's off a single OLT chassis, okay? I can just keep stacking chassis if I need to. Other manufacturers have higher density port counts. I think Corning says they can support 8,000 or 9,000. So here's a much cleaner picture. Again, OLT, single mode fiber to a splitter, and then I'm gonna have 32 or 64 out typically to my ONTs, and then my ONTs are gonna support whatever number of edge devices I decide. 1, 2, 4, 8, 24. Any questions on that? It's pretty simple infrastructure when you clean it up.
UPS is out all the ONTs?
In the Choctaw case, we're distributing 48 volt DC out, which is also backed up by UPS and generator.
You're using a hybrid fiber running 48 volt down the fiber.
That's that fiber copper combo.
Yeah, we're using Corning hybrid that has cable.
Hybrid, okay.
But if you're doing LNTs and you're powering them locally, you can just run them off the generators.
I thought you said you were running power down the fiber.
No.
Okay.
No, we do have, we do have digital, yeah, we do have digital electricity now, but it still requires copper, so.
Is it economical, if I had to put a camera system in, 1,500 cameras, is it economical? I'm seeing the business network on here and everything else. Is it economical if you had to do a system just for cameras?
Depends on your port count.
Okay.
I'll tell you, if you get under about 400 ports, the economics start to not look very good.
Okay.
Now, your 10-year ROI still looks great, but you will not save any CapEx on the front end going PON on a low-density network.
It's a great way to segue in. It's a great way to segue into a PON by saying, let me show you, you'll do a small distribution system. Like I said, we have 1 RU OLTs that will handle X number of cameras and it'll be fine. So it is a possibility to do it, and you can get your customer used to it, and then like, oh, I really like this.
Yeah, and we stopped talking about, oh, you're going to save money, CapEx up front, because it really depends on the size of the building and your density. The larger the building, even on a low density solution, PON will probably start to make a lot more sense. If you're under 100,000 square feet and you're 300 or 400 ports, it's probably not going to make it's not going to be cheaper on install.
And you said this is a
but you got to look at your life cycle.
1,500 camera correction facility.
Okay, well, that's a whole different category.
Yeah, because you already have your PLC in place to run everything else. So you probably wouldn't pay to switch it to a technology.
Your PoE Plus support right there over the slide there, that's just for the devices or that's the max orders, or?
It would be your ONTs.
Okay, so it's limited right now at PoE Plus, no,
Everybody's working on it.
Okay.
So if they're not out, some are out now, and if they're not, they will be shortly. This slide's just really showing us we have all different form factors of ONTs, so we can really kind of fit them anywhere we need them.
The price break on the 400 points, is that just considering the equipment for the network, or are we considering power and mechanical equipment as well?
You'll see your break even somewhere around 400 ports, but no, that's not counting the savings on facility cost.
Okay.
So you can add that back. It'd be a little more compelling. So we've priced an elementary school that actually went in copper. They asked us to come back and reprice it as an exercise on PON. We were pretty much dead even on installation costs, but our 10-year life cycle cost was unbelievable. So assuming that you're going to recable once in 10 years and that you're going to refresh your Cisco gear once and maintain Cisco SmartNet across the board, our Cisco all copper solution was about 1.2 million over 10 years, and our GPON solution was under 400K. So again, if you get your clients thinking long term, it's an enormous cost savings across a reasonable span of time. And for an airport, that's a huge ROI difference when you start scaling into large facilities.
So, Mike, is it Mike?
Greg.
Yeah, you asked what's the downside, and then really the downside is the learning curve to the client, convincing the client that there is an advantage to this technology. We had to do a presentation for Orlando. We actually had to do white papers. Jim and I had to write white papers for our bosses to convince them that we wanted to present this to Orlando. So that's really the downside.
Yeah, if you have less progressive IT folks, the folks who are of the mind, if it isn't broken, don't fix it. You don't get fired for specking Cisco on your copper network. So those guys are a little tough. They're tough to sell.
Our clients under Homeland Security, their IT department, so it's really a big push.
Yeah, the federal government is pushing PON really hard. So believe it or not, they're doing something that makes sense.
So it's not just a change in technology. A lot of our clients are wanting like the 20-year warranty package on the copper. So they're wedded to that idea now is, can we still tell them that, you know, based on the manufacturer we select, that it's compatible with the system, that we can still give you that 20 year on the fiber and then whatever copper is needed downstream. So that's not an issue. We can still give them that.
The single mode fiber infrastructure is still the single mode fiber infrastructure.
And it's not manufacturer X of the ponds, not saying you have to use manufacturer A only, so it's agnostic to that. Okay.
Glass is glass. I mean, everybody has their favorite brand of splitters. There are some performance differences, you know, but based on what kind of, what the manufacturer of the glass is.
Isn't the bandwidth expansion capability something that's also a selling point? I mean,
huge.
Your copper, you're limited to how, at least now, we're limited to how much bandwidth that can carry. When you're going to PON, who knows where it's going to go?
So what we advise our clients is if you build a fiber-rich network, push fiber to the edge. I don't care whether you're deploying active Ethernet or GPON. It'll outlast our careers. We have not exceeded the theoretical limit of single mode glass yet. There is a limit, it's just way out there. And our lasers are getting better and better. I mean, the fact that we're even talking about 80 gig aggregate links is crazy. And the beauty too is if for some reason I want, let's say GPON technology takes a giant leap forward and I want the 100 gig flavor in 10 years, all I'm doing is changing the endpoints. None of my passive infrastructure changes at all. I don't have to open a ceiling tile and pull any cable.
So what Jim and I have been doing, we're members of Bixie also, so we've been going out and we've been meeting with Axis and all these people because we know this, and we've been saying, look, give us an SFP port, because we actually can get an SFP bit that's PON,
right,
and just plug it into something and start running this all the way down to the edge where you just plug the SFP into the camera, and now you get fiber to the camera, and all you have to do is solve your power. So it's a big learning curve. It's not hard. It's really not hard at all.
It's not hard, but it is a very different way of thinking about your network.
Yeah, it's just hard thinking. So. And then there's a lot of people that are still, you know, we say it all the time, we're designing telecommunications in the 20th century, yet we're in the 21st century, and we have technology that will take us to that. So that's where the issues are really lying.
So we talked about space saving. You know, we've seen buildings that we've done comparisons on and we've reduced the floor space by 90%. Those are real numbers. That's work we did. That's not a manufacturer telling us that, because I hold all manufacturers equally guilty until proven innocent. Are any of them listening? Yeah. So we talked a little bit about this. So at Choctaw, we have a fully redundant head-in. That means we have two OLTs that are actually tied together. If one OLT dies, there is no switchover time. It's instantaneous. We're running basically two hot head-ins. There is a management card in each OLT that does load balancing and handles all of that. There is actually a switchover, but it's so fast, nothing other than the management software will know that it happened.
Were you asked to price up both options for comparison of going copper versus
in this building?
Yeah.
Yeah, we have done price comparisons all the way down to getting the PON integrator to give us a full cost solution. And that's where my 1.2 versus 400,000 came from. Those are, one, we built the school, so we actually pulled all the information from the general contractor so we know exactly what it cost to build. And then we actually sent it out to Corning and Zone and got it priced, and that's how those are real numbers. Those are not pretend numbers. So. We talked
Andrew,
again. Yes,
real
sir.
quick question. So, have you dealt with anybody other than Tel Labs on an actual install? And the reason
Zone.
Okay. So the reason I ask is I had dinner with Tel Labs last Monday. They were in for a conference or something in Philly, and they claimed they were the only ones that could do that dual ONT hot failover, or they said they thought they were. So I'm wondering if you've done the dual ONT, cross connect between splitters with anybody but Tel Labs.
It's running today in Zone in that building.
All right, I'll tell Kristen she was lying.
Liar.
And we've been through full network failover testing, so I know it works. Because if it didn't work, I would hear about it. No, it. Oh my gosh. That wasn't on tape, was it?
No, he didn't have the microphone. Sorry.
Okay.
Excuse me, I don't need the microphone, but what is the major IT objection? Is it job security?
It's fear of the unknown.
It's the same concept. Yeah. Because I got the answer for you.
Okay. My question is, what is the major IT obstruction? Because it seems like this makes
It
abundant
seems like
sense.
a no-brainer, doesn't it?
Right, it does. And think about this question. So what do they object? These are the same people that require us to do the IDF and MDF rooms like meat lockers. When the technology and the data sheets say, you can go up to 75, 80 degrees and not impact the performance of the equipment or impact the OS. But they're still entrenched in the old school AT&T world where everything's got to be 70 degrees and everything. So that's the issue. They don't understand, they don't pursue, they learn their technology, they stop, and they don't go like the consultants do and go, wow, we need to look at something new, we need to solve new problems. That's really where the pushback is. It's the same people who are saying, no, got to be 67 degrees in my communications room.
So it's got nothing to do with the job security.
Oh, I think it does.
Well, it might have to
I
be,
think it
yeah,
does.
because they would have to admit that, oh, we don't need as much. It might be budgets, because, everybody. So what's the first thing an IT manager does when you meet him? He pees around his desk. That's all you need to know.
Tony, you need to report to sensitivity training immediately after this class.
I didn't say the other word.
So are you saying that with the IT departments, once they've been through the school, they're hired, they're on, that all their training is like on-the-job training, and they have no further education system that they have to that are required to go through?
It depends on what their certifications are, but I'll tell you that Cisco is actively campaigning against PON. So you have a big player who owns what 70% of the switch market, who is, in fact, they bought a GPON solution. You can still go Google the spec sheets on it, and they killed the product line.
And the copper manufacturer.
Why would they just get into it? Why would they decide to?
Well, so
Because they can't sell a $20,000 switch now.
well, the other part of it too is Cisco's made a very definitive move towards software-defined networks. So if you believe them, and I don't necessarily say that I do or don't, they want to move into that whole white box, black box. They want to own the software. They tell you they don't want to own the hardware anymore. I don't believe that for a second, because that's not the way they're behaving in the market. But if you look at their roadmap, it's less about big, bulky boxes. It's more about running a network management software on a virtual machine somewhere and taking more and more intelligence out of the physical switch plane. So I don't think they've quite made up their mind what to do with GPON, but I can tell you the big carriers like AT&T and Verizon are not waiting around for somebody to convince them it's real. They have bet their future networks on an all-fiber infrastructure. It's just what they're going to do.
Are you willing to share the cost comparison between the traditional
Sure.
copper?
Absolutely. We're done at 11:45, right? I mean,
Yeah.
15 minutes. Okay.
All right. You said this is a 1 million square foot office building.
Half a
And
million.
500,000 square foot office building. Can you share with us the bottom line numbers on the traditional copper cost versus the PON cost?
I would if I knew it. I'll see if I can find it. We've asked for all those numbers from Manhattan Construction. You know what it's like getting information out of a general contractor.
Yeah.
So I will work on that for you though. I can give you the comparison for the elementary school. I'm much smaller, but it's only 100,000 square feet. But
do you have like a multiplier if it's?
No, because there's so much variability between, because the elementary school design is much simpler than the Choctaw design. We're not using a 48 volt distributed power plant. We're not doing all of the fancy stuff. So the school is going to inject power at the splitter location, and in some cases they're going to just use a wall wart to power the ONT at the edge. So it depends on how critical it is for you to keep your network up. Now your ONTs can reboot in a few seconds. So most people, especially in the K-12 world, they're willing to take the hit on a few seconds of downtime.
Hey Drew, can I add one comment to this space, and I'm sure Joe can back me up doing airports, that one of the things you asked about inertia from IT departments about going to PON, one of the space savings considerations that we've run into is the PON can save space, but they still, maybe an airport, for example, wants distributed NVRs for video recording, so that they don't want all their NVRs in their MDF, so you still have to have space for that. And then maybe they've got other vendors with equipment that they have to service, and they want distributed rooms. So in Orlando that Tony mentioned, we still ended up with a pretty traditional floor plan because of other factors having nothing to do with the PON. So that's where you can find these policy issues or other completely unrelated systems or network connected systems that restrict how much floor space you can save, and by no fault of the PON. So you still end up with more fiber, less copper, and lots of other benefits, but you have to find out what else is out there that might still need these rooms. So,
very good point. Yeah, if you have a large access control and video management systems deployed in your facility, you're probably not going to get rid of all your IDS. Now you could probably reduce the number you have. Marriott's are still built with IDFs, but they're on every third floor. You know, they've reduced the amount of the number and volume of them.
I'm working with the Port Authority up in New York, and we have a large one, and I have right now in a parking garage. I have a parking garage right now. It's got something like 64 communication rooms, because it's a very large garage. And we're going to talk about this in the next couple days. We're going to show the port that, look, we don't need all this for what you're using. We've got a lot of rooms with nothing in them but fiber coming through them. Mm-hmm. So we may see some changes there, some concepts.
Yeah, the parking garage on the Choctaw campus is actually fed from the main building. You know, we're just single mode fiber run. There is an actual IDF closet that we left in there to house access control head and stuff. But this is what's actually in use under the floor at Choctaw Nation. So this is a 2x2 floor box. You can see this is our power distribution sitting in the floor. It is not waterproof, as we discovered when they broke a main water line and flooded 4 of them. They did not opt for the submarine grade power splice. Our optical splitters are sitting here. This is a 32 port splitter. It's hard to count all that. So, and then you've got all your patching going out. So very clean. These boxes, I'm sure, haven't been opened since we did commissioning, and they're all covered up under carpet tile, so they're not too easy to get to. But you wouldn't know they're there. They are on a grid system, so the IT people can find them once all the carpet's in. That's a 2x2 box.
2x2 box, okay.
They also, for all of our ceiling devices, so all of our building automation, all of our WAPs, all of our cameras that are ceiling mounted, and there's a host of occupancy sensor stuff that's riding their data network, all comes to a ceiling enclosure. So similar, pretty much the same setup. I just didn't have one of the box fully populated because I wasn't going to climb that ladder, so sorry. So very clean, very easy to maintain. They rarely ever touch any of this gear out in the field.
How long has it been operational?
It's been running up in various stages since March. We'll get to the implementation. They are a little harder to commission because people don't understand how they work, not because they're technically harder, but you have to overcome a lot.
Going back to your floor boxes and ceiling boxes, typically we'll put access control and cameras watching the IT rooms.
Mm-hmm.
Are you doing any type of security on those floor boxes and ceiling mount
This
racks?
client did not want tampers, but we certainly would have put them in had they wanted them. But and you would have to know where these were to ever find them. These ceiling boxes are actually above the ceiling tile.
And again, it's fiber. It's fiber and it's encrypted fiber. So tampering with, the most you're going to happen is disconnect it. And you're going offline, and your management program is going to tell you where you went offline.
Yeah, if you take power down or you disconnect fiber, you will alarm it immediately. So, and if you plug into,
the splitter,
we can shut ports down on the ONTs, and I can actually do MAC address restrictions. I can do all of that stuff. I can lock my network down nice and tight on an all fiber infrastructure.
Originally, that was one of the selling features.
I can't stop stupid people though, but I can lock down
one of the original features was the fact that it was a secure network. That's why all the SIPR nets are now being mandated to be PON. That's why the government has adopted it, because it's much more secure than the traditional copper.
And if somebody messes with it, they know immediately.
Immediately.
So.
Big network reliability.
No, yeah, there's a lot of positive. The biggest issue right now is it's relatively new in the enterprise world.
Yes.
So it's got its pains. Just like we just attended the OSDP's conference, which is going to replace WIGAN, but it's not there yet, and it's because we get people that are I've been doing this since 1970, and this is the way we've always done it.
So I was so skeptical about PON, I wanted to go see one that was actually up and running. Billings Public Schools in Billings, Montana. Yeah, well, we do a lot of education. I wanted to talk to an actual education client. So don't go there in the winter, but it works well. Behind this pretty facade is a 100-year-old building, and they couldn't get cabling into the areas of the building because they wanted to go all 6A. There just was physically no way to do it. So PON won out, and actually PON in this historical building renovation turned out to be $140,000 cheaper when you factored in the cost of telecom rooms, the deletion of the MEP systems to support all of that, and then the actual infrastructure was a lot less expensive. So there are some compelling case studies, but it's really a case-by-case basis.
The labs, Sandia Labs, is over 4 years old and been operating.
Sandia Labs did a rolling telebs deployment. It took them 3 years to deploy it, so it's actually been running 7 years. Parts of it have been running 7 years. So that's a trick question. How many telecom rooms are in that 150,000 square foot building? That's it. So all their active gear, you're looking at it. It's not very well dressed in, but that's what's running it. They liked it so well, they deployed it in their middle schools. This is a brand new middle school. It supports 1,200 kids with a single IT space. They used centralized splitters, so all their splitters happen to be in this one central closet. It's just the way they chose to deploy it. It's actually a little more expensive to centralize your splitters, but it makes them comfortable because it looks more like the way they used to do stuff. So here's the case study we got to wrap up. So Billings case study, they deployed it in 22 buildings. They saved $140K per campus. Their Mac work, the teachers can now move all of their own equipment. They don't have to call for a service ticket. They literally unplug the ONT from the wall. The way they deployed it is they have a fiber port on each of the 4 walls. If the teacher decides to flip the room, she unplugs it, moves it over there and plugs it back in, and it auto recognizes and reconfigures all their devices. So they went from 40 tickets a day to none. And he said, think about Billings. It's a small town, but it's a large geographic area. In the winter, it can take them an hour to get between buildings. So if I'm the network guy in Billings, I'd want PON too. We already talked about power savings. You kind of do the math. It's pretty easy to understand. This is a compelling number from Sandia. So after they completely flipped their network from Cisco to Telabs, now they're still Cisco at the core, they actually monitor their power usage through their billing management system. They showed a $20 million savings in the 5 years they ran the service. Now I'm sure they wasted that somewhere else. It cost them $25 million to do the study, yeah. And we talked about this too. They went from 15 techs, network engineers, down to 1. So they have one guy, his sole function is to log in every day and make sure SolarWinds is happy and there's no network segments that are in trouble. And that's 200 plus buildings and growing. So that's the oldest and the largest PON site that I know of in the United States.
There's a couple libraries out in San Francisco.
So we have about 2 minutes to talk about design. So design considerations, and you'll get this presentation, we'll send it out. You got to understand what network services you want to run across a network. We had a big fight in the early days with Choctaw because nobody wanted to be on the PON. Surveillance wanted to be on their thing, and billing automation didn't trust it, and all these folks. In the end, we have a single converged network and everybody's on it and it works flawlessly. So you got to understand how you're going to power everything, right? So we've got PoE. We talked about I can do centralized power distribution. I can power really at the splitters if I want to inject power there, or I can power the device, the ONT at the edge with a, they do actually make ONTs with batteries in them if you want to do that. And then what devices am I going to connect to it? This is where you have to do some bandwidth planning and understand how am I going to spread my heavy bandwidth devices across my ONTs. Again, as our GPON standard or our PON standards grow, bandwidth will become less and less of an issue. So bandwidth, PoE, where are you going to put them? Are you going to put them in the wall? We've seen some clients actually Velcro them into the modular furniture, and then it just looks like traditional, they're using traditional faceplates in the furniture. You can put them in the ceiling, put them in the floor. You can, billings, they're on the teacher's desks, just sitting on the desk. So they're very unobtrusive, and they use less, they only use a couple of watts of power. Any thoughts, Tony? You're looking at me like...
No,
okay.
I was just thinking that movable furniture we've seen them put up underneath the desks.
Yes, we've seen, they actually make brackets. You can attach them to the underside of the desk. Depends on how you power them. I can centrally power them with a hybrid cable.
Isn't there, I mean, you were talking about Choctaw being centrally powered. 48 volts, yes, that will go a long way. But you eventually get into voltage droppage, right? So are you interspersing? When you say centrally powered, are you?
So we have 2 main power distribution hubs in that building, so each wing. Okay. So none of our runs are more than about 300 feet, and then you just upsize your copper.
Plus you can power out at the splitter.
Yes.
You don't have to power at the OLT.
Well, that's actually what we're doing. So your 48 volts is being pushed from the main power plant out to the splitter location, and then we're actually going class 2 distribution from there, using digital electricity. How many watts did you use that at the splitter? Oh, I think the ONTs, depending on, if I'm not using PoE, they're very low usage devices.
But you said you're using 48 volts out there to power them?
Yeah, at Choctaw we are. Yeah, 48 volts DC is much more efficient.
No, understood. But and then the distances that you're saying, you're running copper or like a composite cable.
Right.
I was just wondering how many watts that's using to figure out distances as far as how far you can go.
Yeah, I don't have the calculations in front of me, but we did all the spreadsheets to.
Well, I mean, typical ONT, how many watts do you know?
Typical, well, it depends on how many ports and what flavor of PoE it supports.
Okay. All right.
So, yeah, I'm sorry, I didn't mean to not give you a non-answer, but there's not a standard there.
Quick question, as you start pushing switches and data drops out in the field, are we not dealing with cyber issues as far as somebody tapping into that data drop?
No more so than you would on a traditional network.
So why would you not have separate networks?
What do you mean?
A couple of slides ago.
A couple of slides ago, you mentioned that the client decided to just have everything on one network.
Right.
When thinking about cyber security, I tend to tell my clients to separate their networks so that if a device is compromised, you can't jump from one to the other.
So, but you can accomplish that with virtual separation. I don't have to do physical separation to do that.
Correct.
So your network security is only as good as your network security, regardless of whether I'm traditional copper or LAN. You're bringing up a great point, but that's kind of that conversation doesn't really change whether it's PON versus copper.
Okay.
You know what
I
I
guess I was stumbling over, you said one network, and I wasn't thinking you were separating them virtually.
Oh, no, everything's segmented off in their network.
Okay.
Yeah, Choctaw's a little obsessive about how they VLAN off all of that stuff. So, and they're very tight with all their firewall controls, and it would be very difficult for you to do damage for very long. You can absolutely get in, but they're going to figure it out pretty fast. So, I'm sorry. Anybody else?
Yeah, I have a question. Yeah, are the ONTs hardened for exterior use?
Yes, you can absolutely buy hardened ONTs. Telabs probably has them. Well, Telabs, Zone, Calyx, they all build pretty rugged.
Remember, it came from the outside.
Yeah, they're intended. Yeah, they were built really to sit out in unconditioned space. So, short of really extreme situations like putting it in an EMA enclosure in Phoenix, you know, they're going to work pretty well. The last thing is you need to, picking your ONTs, you want to understand what services you want to deploy over the ONT. Do I need to do RF distribution? Do I need POTS? I can get a good old RJ11 off the back of that if I want it. And how many ports do I want to on my ONTs? And that's usually not just one answer. You're going to usually use a variety of different ONTs on any given enterprise project. You may have one flavor for conference rooms, a different flavor for cube farms, a whole different configuration for your hardwall offices. I mean, all of that's pretty normal stuff. And then the old power conversation. You got to decide how you want to power it. So local power at the edge, at the ONT. Am I going to inject power at the splitter location, or am I going to do a central power distribution? And most of the ones we've done have been a combination of those, of 2 and 3. But I will tell you, the 48-volt central power solution is really nice. It's very elegant, it's very clean, it's easy to maintain, but they ain't cheap. So if you have a price-sensitive customer, you don't want to lead with that.
You talk about central power distribution for 48 volts. You talk about like a single output, you need multi-output. How many, you know, the question is how much power do you actually need? Because when we offer 48 volt devices or power supplies, and you know, I'm wondering if that's something that we have existing now that could provide power for what you need. Or is it something new that has to be created?
Well, so what we do is, again, we do all the calculations from the edge all the way back to the core, and that's how we calculate how much power we need.
Correct. So ONT right now, maximum number of devices, how much?
You can buy them all the way up to 24 ports.
24 ports and provide 30 watts each?
I don't think anybody's given us that much power.
Right. So I guess the question realistically was, what's the maximum amount of power that you're going to draw out of there, and that's what needs to be created for a power supply.
Right, and that's where we have to understand what devices you want to connect to your ONTs and what the power requirements are.
Okay.
Yeah, there's no one answer for that question. So
So, yes, we could use Altronics.
No, I understand that. I'm just wondering, you know.
But generally, just like we did in correctional, we use DC rectified power supplies.
Right.
With hot swappables. And you'd rack one of them, and we probably could run, you know, most of the power off of one DC rectifier.
Yeah.
Right. I mean, we have 48 volt rack mount, single U, 300 watt power supplies. Is that enough? You know,
Depending on what
depends
your
on the
edge is,
installation.
yeah, sure.
Okay.
But there would be a lot of applications where that's perfect.
Okay.
So, last conversation is splitter locations. We talked about this already. Are you going to push them out towards the edge, like what Choctaw did? They're all under the floor, as close to the work zone that we could get it, or are you going to put them all in a central IDF, for example? So, there's no right answer to that question. It's really based on what your goals are, what your client's comfort level is. There's no right or wrong answer to that. I was wrong. Last thing is redundancy. So depending on what manufacturer you buy, you could be 5 nines out of the box without doing anything special. Again, telco grade gear, right? It's intended to sit in the central office. They are full of little tricks to keep your network running. The way pretty much everything we're going to recommend you at least put in a spare PON card. So if your PON card fails, it'll automatically switch over to your spare. But you can do redundant OLTs, and you can configure them either in a load sharing. Now, again, Tel Labs might argue about exactly how they're doing. What Tel Labs is really telling you is they're arguing about nuance on how they actually manage the failover. It's marketing. Their failover may be a little more elegant than the next guy's, but they're all still going to work. And then redundant fiber. Am I going to use 2 bi-splitters? Am I going to take 2 fibers to every splitter, or am I not? You know, those are. And then how far am I going to take backup power, right? Am I going to go UPS and generator, you know, and again, we have to have the load conversation about, we got to back into what my loads are from the edge. Any questions on that stuff? I'm kind of rushing through the last one because we're late, but I don't want to stand between you guys and a lunch. So.
I have a question. You showed before that you had a switch, and then you can put another switch at the end. The question is that dictated the limit of what you can do, limited by the number of ports? Every time you distribute that light splitter, the light loss per port is an issue? Is that the limitation?
Yes, I can only split so many times before I don't have enough power left.
Have a DB budget for it that you can't exceed.
Right. Is a 24-port budget bigger, smaller, equal to like a 2-port, or I don't know how that works?
Oh, okay. So you're talking about sharing bandwidth at the ONT. Yes. So if I'm on a traditional PON port, right, I've only got 2.5 gig to share across. So I have to calculate what my bandwidth is required for each segment of my network. Does that make sense?
And this is where the management software comes in, because it's looking at ports that are not active and allocates resources to active ports.
Absolutely. So the way PON works is I can dedicate a specific amount of bandwidth to every port, but I can also set a threshold for burst. Say, okay, well, I want every port on that ONT to have 100 meg available. But if somebody needs a gig, I can burst to a gig. So that's how so the ability to dynamically manage bandwidth is one of the shining examples of why we like PON and GPON and XGPON and NGPON2 and all of this. So so in the fixed copper world, we're dedicating a gig to every port, and the average workstation user in the average office in America that use their link 10% of the day. So we have all this bandwidth that we're just distributing in a fixed configuration, and we have no ability to dynamically manage that bandwidth from the access layer out. You can certainly manage it at the core, but.
So is that burst rate guaranteed to go across?
Depends on what platform you're using and what management software you're using. But yes, generally speaking, yes.
All the manufacturers have their own management platform. And yeah, you could set the parameters however you want. But basically the whole theory behind it was looking at all the usage, and nobody's using the full bandwidth of their network. So what they're doing is they've taken advantage of that concept and then said, okay, well, where we're not using anything, let's kick it over to somebody that does need it. You're moving a CAT scan down a file and somebody is not on their PC logging a patient in, take his bandwidth away, he's not using it right now.
Absolutely true. Now you can understand why the carriers love GPON, right? I don't have a bunch of dedicated fixed bandwidth that's just sitting there unused. So the ability to manage that is huge.
The reason I asked that question is because when you have these cameras like he was talking about, and it's a 4K pan-tilt zoom camera, it's on VBR, it sits nice and fine. The moment you move that thing, that burst rate's going to go up really high. And so is that a guaranteed delivery at that point?
So I can go in and dedicate whatever amount of bandwidth to that channel that I want.
On demand. So that it's
There's a normal bit rate, but there's a burst.
So I would calculate my worst case scenario, and I can dedicate that.
Oh, you would allocate the entire. Okay,
Yeah.
gotcha.
So one of the things you want to do is you look at your distribution on your ONTs, and if you put cameras on there, then you can use something that uses a low bandwidth regularly, so you can balance your ONT. You don't put like 5 cameras and then maybe a CAT scan machine all on the same ONT.
So, yeah, so is it Alan? So yeah, the question is, he's hitting it on the head. We wouldn't ever put like 4 4K cameras on a single ONT. We'd spread those across, and then I will dedicate whatever bandwidth I want to the port that's using that the camera's plugged into to make sure I don't have an issue.
Oh, understood. No, the only reason I asked that question is there are several schemes to mitigate against bandwidth, but those mitigation schemes sometimes causes very, very high burst rates. This is why I was asking the question.
Yes, understood. Yeah, we can plan for all of that. Thank you all.